for handling deadlock. We understand before that there was 4 conditions. When those conditions hold simultaneously, the deadlock may or may not occur. The first condition was mutual exclusion. The second condition was hold and wait. The third condition was no preemption, and the fourth condition was circular wait. We understand each of them, and when those conditions become true, the possibility of deadlock will rise and increase, and how when those conditions will become false, then what will happen. So dear students, now we are going to study the methods for handling deadlock. So the following 4 mechanisms, the following are some mechanisms to ensure that the system will never enter a deadlock state. The system mean what? The system mean the system processes and threads inside a system, okay? These mechanisms will ensure mean they will try to keep the system in a safe state. To keep the system in a safe state. Safe state means secure state where possibility of deadlock will be very less. Okay, dear students, we understand that the following are some mechanisms which will ensure that the system will never enter a deadlock state. So the first mechanism is deadlock prevention mechanism. Deadlock prevention mechanism. What is deadlock prevention mechanism? The deadlock prevention mechanism means they will try to prevent the system from the deadlock situation. How to prevent the system from the deadlock situation? Very simple. You have to just solve the cause of deadlocks. Cause of deadlocks was what? The causes of deadlock were 4 conditions. So try to solve those conditions. Do you remember? I told you that when those conditions become true, the possibility of deadlock is. In the deadlock prevention, we will try to false those conditions. Okay, you know the condition can be false and can be true. If they become true, the possibility of deadlock. But here we will try to false those conditions. Like we will try to avoid mutual exclusion. We will try to handle hold and wait. We will try to remove the no preemption. We will try to remove the circular wait. Okay, when we solve those problems, it means the system will be prevented from the deadlock situation. Very simple, dear students. In deadlock prevention, solve the causes of deadlock. Causes was what? The previous 4 causes. Very good. The second method, which is for handling the deadlock, is deadlock avoidance. Deadlock avoidance means they will avoid the deadlock, or they will avoid the system to enter to the deadlock situation. How they will avoid the deadlock? They will try to ensure that the system will never enter in a deadlock situation. Okay. So abhi bhi Farhad abhi bhi chika tha mera. Okay guys, so the second handling method was to ensure that the system will never enter in the unsafe state. Remember, I will explain later what is unsafe state. Okay, what is unsafe state? I will explain later that what is safe state and what is unsafe state. But right now you have to just remember and stick this definition with the deadlock avoidance label, that the deadlock avoidance means this deadlock avoidance mechanism will ensure that the system must remain in the safe state and will never enter in the unsafe state. Maybe you guys are thinking that how the system will follow this mechanism. Remember, the system will use very complex algorithms for this purpose. And those algorithms will run every time. and they will try to keep your system in the safe state, and they will not let your system to enter in the unsafe state. Okay? Just like, you know, you guys are using your computer, and we are in your computer, you guys are opening multiple processes, browsers, multiple tabs of browsers, and multiple sub-processes inside those tabs, file downloading, Microsoft Word, Excel, music, whatever. It means you are doing a lot of things, but you know, you are not facing deadlock. Why? Because at the background, there are multiple algorithms which are trying to keep your system in the safe state, and which are trying to not let your system to goes into unsafe state. Okay, guys? So the second method means they will ensure that the system will not enter in the unsafe state. Don't think about what is unsafe state, because we will explain this later. The third method is for handling the deadlock is deadlock detection. Deadlock detection. Remember, dear students, when we use deadlock prevention and deadlock avoidance, these two methods, it doesn't mean that our system will not enter in the deadlock situation. No, still there is possibility of deadlock. Still there is possibility of deadlock. When there is still possibility of deadlock, then the system must be able to detect the deadlock, that where the deadlock occur, and which processes or which threads are in the deadlock situation. So it means, dear students, beside the prevention and avoidance, the system must able to detect the deadlock, that which processes and threads are in the deadlock situation. So in the third method, the system will try to detecting causes of suspended progress of a process. Suspended progress means a process which is suspended for a particular amount of time. And the system will try to detect or try to understand what are the reasons behind that suspended processes. Is the lack of resources? Is they are waiting for a particular event? What is the reason behind it? Or is there a deadlock? So dear students, in this third method, the system will try to detect deadlocks, that which processes are and threads are waiting and why they are waiting. So when the deadlock is detected, then the system must able to recover the deadlock. The system must able to do what? To recover the system from the deadlock situation. So dear students, the deadlock recovery means retrieve the system from the deadlock situation. It means that right now, okay, let me tell you is once again, the deadlock avoidance will try to keep your system in the safe state, and they will not let your system to go to the unsafe state. Okay, very good. So the deadlock detection will try to detect is the system is in the safe state or unsafe state. When the system is found in the unsafe state, then they will let the deadlock recovery algorithms that the system is in an unsafe state or the system is in a deadlock situation, try to recover the system or try to recover the processes and threads from the deadlock situation. Sometimes, you know, you guys are observing, sometimes maybe you guys are working in your system, but suddenly your system is hanged and all the open tabs, application, whatever you open will close and your system will take us refresh, restart. Or you will say that your system is rebreathing. What does it mean? It means that your system was in the deadlock situation and the operating system recovered the deadlock, your system from the deadlock situation. How they recovered? Because they close all the applications, they close all the processes. But sometimes you will see that you are trying to open a particular application in a very consumption time, but that application will be not going to open. Why? Because the system is not letting that process to be open. Why? If that process open, the possibility of deadlock. It means that you guys are already observed such things, okay? And after these things, you will understand that your system is actually doing to avoid the deadlock, and your system is actually doing to keep your system in the safe state. or maybe sometime the system is doing something to recover your system from the deadlock situation. So dear students, these were the deadlock handling methods, okay?
Sir, I have one question.
Yes, please.
What is the difference between deadlock prevention and deadlock avoidance?
Okay. Deadlock avoidance, deadlock prevention. Deadlock prevention say solve the 4 conditions and make them false. Okay, you don't need to do anything else. Deadlock avoidance say keep the system in the safe state, use the resources fairly, and not let the system to use the resources unfairly. And one thing more, that for the deadlock avoidance, the system will use special algorithms, and based on those algorithms they will try to allocate the resources fairly. Okay, there is not a major difference. The major difference is just only that the methods. Okay, actually the purpose of both deadlock prevention and avoidance are the same, that they are preventing the system from the deadlock, but the mechanism is different. That deadlock prevention will follow different mechanism, deadlock avoidance will follow different mechanism. Otherwise the purpose is same. They are trying to save your system from the deadlock. Okay, does it make sense?
Okay, sir. Thanks.
Okay, guys. Okay, as I told you before, that the first thing was what? Deadlock prevention. This was deadlock prevention. And it means what? Solving cause of deadlock. Let's try to understand how we can solve those 4 problems, okay? The first thing which I told you, deadlock prevention means necessary conditions should be false. Restrain the ways requests can be made. First thing, mutual exclusion. Solve the mutual exclusion problem. How? Not required for shareable resource. Okay? It means that the mutual exclusion handling method is not required for shareable resources, but the mutual exclusion handling mechanism must hold for non-shareable resources. What does it mean? It means this. Let me explain this with the help of diagram. Dear students, for example, I have a process, and this process is a single instant process. When single instant, it means it's not shareable, it's dedicated resource. Here is P1, okay? The P1, and here is the P1 make a request, resources free, resources allocated. Here is P2. P2 also want to make a request. Okay, P2 want to make a request, but the system will say, no, you are not allowed to make a request, because this request will create problem. When this resource will become free, then the P2 will be allowed to make a request. Remember, in mutual exclusion for the dedicated resources, you must stop P2. You must stop P2 to not make a request. Let's suppose, let's consider the previous examples. Azizi back example. We had 3 customers, Habib, Idris, and Shakur. These 3 were the customers. Okay. If 3 of them come at the same time, let's suppose I am a cashier, I am a bank, then what will happen? One person, Shakur, will be served. The cashier will be allocated to Shakur, but the Idris and the Habib will wait in a request form. They are requesting, Habib is also requesting, and they're also requesting. So in this was creating a problem, and now we are solving this problem. So how we will do this problem? We will create a mutual exclusion mechanism. Okay, we will create a procedure to solve this mutual exclusion. So mutual exclusion mechanism. How? I'm going to explain that, okay? Okay, complete this mutual exclusion mechanism. So I will say, I'm a bank. I will email to my all customers, please, before coming to the bank, have an appointment. Have an appointment. Yeah, I know it's not applicable, but let's try to think about this, that if such thing occurred, it will be very good. So the bank say to Shukur that you should come on 9 p.m. fixed 9 p.m. You should come, because at this time I will be free, and when you come immediately I will be allocated to you and I will solve your problem. In order to keep this Idris and Habib from request, so I will say to Habib, please come on 9:05. Enter to the bank on 9:05. When they enter to the bank on 9:05, at that time, the bank will be free and the bank will be allocated to Habib. And the Habib will make a request, and immediately bank will be allocated. So they will not face any waiting time. They will not face any waiting time. Waiting time means requesting time. That just like we are sitting, Khalid is going to a bank, so he will print a ticket for him and he will sit in a queue on the chair. So for unknown time, he will be sitting. So if such thing is applied, like mutual exclusion method is applied, then no one will wait. Every person will come on their own time, because the system is telling them that you should come on your own time, and the system is trying to discourage the mutual exclusion culture. Okay, so this was Idris, and it will say to Idris that you should come on 9:15. So when see, now Habib, Idris is not here. Idris time is what? 9:50. Okay, Idris is not here. Habib is here on 9:05. Habib is interacting with the bank. When Habib is finished, the bank is free, and that 9:15 will reach. Idris will arrive, and Idris, without any waiting time, Idris will make a request. The bank is free and the bank will be allocated. So the problem is solved. Clear? So this was mutual exclusion method for the single instance resource. Let's suppose that this bank have a single cashier. This bank have a single cashier, etc. Is it clear, guys? But I told you that the mutual exclusion method is required for the single instant resources. But what about a bank which have multiple instances? Like what about this process or this resource? This resource have 2 instances. Can P2 should not make a request now? Of course, P2 can make a request. Why? Because the process is shareable. The process have 2 instances. No problem. The system will not prevent the P2 to make a request. So that's why the mutual exclusion is not required for shareable resources. Let me give you the bank example. For example, right now, the bank have multiple cashiers. The bank have multiple cashiers. Cashier number 1, cashier number, let me get 3 cashiers because there's 3 customers. Okay. The bank have 3 cashiers. And if now the Shukur, Habib, and Idris, all of them arrive at 9:00 a.m. So what do you think? Is any of them will wait? Of course not. Request, allocate. The Idris will see who is free. Counter number 2 is free. Go to counter number 2, and counter number 2 will be allocated. Habib will see who is free. Counter number 3. Allocate to counter number 3. So if you have a shareable resources, no problem. But if you have non-shareable resources, then you have to discourage other processes from making requests, because you have to prevent the deadlock. Is it clear here, students? Okay, hope it's clear for you guys.
Clear, sir.
Yes, it's clear.
The second thing was that we have to solve the problem of what? Hold and wait. We should solve the problem of hold and wait. How we can solve this? Let's first try to read these things. Must guarantee that whenever a process, see here dear students, must guarantee that whenever a process requests a resource, it does not hold any other resources. Very simple, very simple. When a process is going to make a request, that it must be sure that is this process is already holding another process, another resource or not. If he is holding, so don't let him to make a request, because it will create a hold and wait situation. How? Let me explain this. Okay. For example, do you remember the previous example that I had P1, sorry, I had R1 and R2, R1 and R2. They both are single instant resource. And I had two processes, P1 and P2. Now I am going to remove the hold and waits. Okay, see how I can. And this is my R1 and R2. R1 and R2. Okay. Okay, guys. So P1 make a request to use R1. Very good. R1 was free, so R1 is allocated. Done. P2 is come. P2 see R2 is free, so they make a request. And R2 was free, so R2 is assigned to P2. Okay. But the P1 is claimed that R1 is not sufficient for me. I need R2. So the P2 is going to make a request. For who? For R2. But before making a request, here the operating system will ensure that is P1 already have a holding resource? Yes, you can see here that P1 is already holding R1. So now the operating system will say to P1, you cannot make a request. We are really sorry. Why? Because you already holding R1. If R1 is not sufficient for you, then release R1 and go to the waiting state. Then why you are wasting the R1? When R1 is not sufficient for you, then you have to go back, you have to wait until the sufficient amount of resources are become available, then you have to come and we will deal with you. Otherwise, you should stop making requests for more resources. So dear students, through this way, we can stop hold and wait situation. Hold and wait situation. Is it clear? If it is not clear, let me give you the banking example. For example, Habib, this previous example, Habib was with the counter number 3. Habib was with which counter? Counter number 3. Habib is trying to withdraw, for example, 5 million US dollars. Suppose they are holding this cashier and they are demanding for this much amount, where the cashier say, I don't have this much amount. Then the Habib at the same time, Habib called to the second counter. Hey, mister, this is my card. So you both of them should collect this much money for me. Okay, see, if the hold and wait situation will be like this, that Habib right now is holding two counters, counter number 3 and counter number 1, where both counter cannot satisfy the request of Habib. Why? Because both counters don't have that much resources. And here what occur? Hold and wait situation occur. And now we will try to solve the hold and wait situation. How we can solve this? We can solve like this. Okay. Habib is demanding for $5 million, where the counter number 3 say, I don't have that much money. So Habib is trying to call to counter number 1. The bank manager will say, please don't call to counter number 1. Why? Because he's already busy with another customer. So you should stay with the counter number 3. If the counter number 3 can solve your problem, it's okay. They will take some time, but they will solve your problem. If the counter number 3 cannot solve your problem, then please release the counter number 3 and go back and have a very special seat for a long time because we are calling the central bank to have money for you. Then what will happen? Then the Habib will release the counter number 3 and they will come back on the seat they were waiting, because if they reserve the counter number 3 for a long time and where the counter number 3 is not satisfying the request of Habib, so the counter number 3 will be considered wasted. They will remain idle. Okay, and Habib will be in the deadlock situation. We are trying to avoid deadlock, so the Habib should be removed from the front of counter number 3, and Habib is now where? In the waiting state. They are not interacting with any counter. So dear student, the same thing will apply here in the system, that when a process is going to make a request, the operating system will ensure that the process must not hold any existing resource. So if he is hold any existing resource, that he must release that and he go back to the waiting state, because the holding resources is not sufficient for him and he should release him. Is it clear, dear students? So this was the second condition, and why this mechanism we can make false the second condition. Okay, let me give you one more tip. It doesn't mean that the P1 will wait for a long time. No, the operating system must have a database for the such type of processes, that how many processes are waiting and how many processes request how many resources. Whenever the two R1 and R2 become free, and whenever the sufficient amount of resources become available with the operating system, then the operating system will let the P1 to execute. Will let the P1 to execute. Why? Because now the OS can satisfy the request of P1. Is it clear, dear students? But there is one problem, that may sometime P1 will wait for a long time. Like Habib. Habib Bechara is sitting here in the waiting queue. So he's watching to the clock that he 5 minutes, 10 minutes, 15 minutes. So for how much time will wait? If the manager is good, and the manager will keep in their mind that a customer, a VIP customer is waiting, he is demanding for $5 million US. So he should immediately call to headquarters or to head office that one of our VIP customers is here, and please send this much amount. Then if the manager is working, and maybe within few minutes, the sufficient amount will be received to cashier number 3, and the cashier number 3 will call to Habib, please come and have your amount. Now we can satisfy your request. Is it clear, dear students? So by this mechanism, we can solve the hold and wait situation. Okay, guys, let's continue. No preemption. No preemption mean, let me explain this. Okay, we should make what? No preemption false, okay? If you remember, when the no preemption become true, the possibility of deadlock, we should make it false. False, when you make it false, it means your operating system must have what? Preemption. Your operating system must have what? Preemption, because no preemption is the opposite. Preemption is the opposite of no preemption. And let's try to understand how we can make it false and how we can make it preemption. Very simple. I have multiple resources. For example, there's 2 resources. Both are a single instant resource. P1 and P2. P1 is holding this resource, and P2 is holding this resource. R1 and R2, P1 and P2. And this is, let's suppose, our operating system. Okay. So there is another process. This process is a very good process. Okay. The process 3 is waiting there because the system is not letting him to make a request. Why? Because R1 and R2 is already busy. They're already held by P1 and P2. Good. P3 is waiting, where P3 is a very much important process, but for how much time they will wait? Let's suppose the P1 is not going to release this R1 and the P2 is not going to release this R2. When they are not going to release this and the P2 waiting time is going to increase, then the operating system will come in by force. They will take back this R2 from the P2 and they will allocate this to P3. This is called what? Preemption. The OS must take back the resources from a process when they are not going to release the process, or if the process is not important. Is it clear? Then the OS must take back the resources from the holding process and they will take them to the another waiting process. Clear? If it is not clear, let me explain this with the help of the previous, our traditional example. Okay, I have two counters in the bank. In front of one counter, Shukur is here. Shukur occupied this one counter. The second counter is occupied by Idris, where Shukur is a very friendly person. In this cashier is the friend of Shukur, and Habib is Idris is also very friendly. So let's suppose the Idris already have their deposit and Shukur is already have their deposit, but they have some funny dialogues that they are continuing their discussions where Habib Bechara is waiting here. For example, Habib is a very good customer, so he is sitting here. He is not making any complaint. But for a long time, the A and S, Idris and Shukur, is holding these two counters and they are not releasing the counters. So the bank manager, which is sitting here, he is observing that these two customers are not releasing the counters where the cashier is also busy with them. And there is another customer, which is a very good customer, and he's waiting for a long time. Then he will come. He will say, hey, mister, what are you doing? Is it your working hour or it's your gupshup hour? Okay, so this counter number 2 will say, okay, sorry, boss. So they will say, Idris, you should go by. The Idris will release this counter, and this counter will be assigned to Habib because he was waiting for a long time. So this is called what? This is called preemption. The branch manager had the preemption capability. That's why he preempt and he retake back the counter number 2 from the customer Idris and he assigned them to customer Habib. So this is called preemption, and we make false the no preemption false. Okay, guys? And you know that when the no preemption, in the case of no preemption, the branch manager will say, yeah, I don't have any authority to go and to retake the counter number 2 from the Idris, so I can't do anything. So the Habib should wait for a long time. Then the Habib will be in the deadlock situation. And that was the previous case, okay? In now case, this operating system must have the capability to retake or to take back the resources from a holding process and allocate them to our other waiting process. This is called preemption. Is it clear? Okay, guys.
Clear, sir.
Let's have the final no circular wait. Okay, guys, we should take a break. Shall we take a break? 5-minute break, okay? Just 5 minutes break. Take a coffee, take a tea, because you have to keep yourself fresh. Just 5 minutes. From 10:25 to 10:30. Welcome back, dear students. Okay, so the final conditions which we are going to make it false to prevent the deadlock is circular weight. And now we have to deal with the circular weight. Dear students, the solution is for this method is that a system must create a total list of all the resource types on ordering base. Okay, the system create a total list of all resources. It means that a system must create a database for the all available resources in an order base. An order base means in an incremental order base. And required that each process requests resources is in an increasing order of record. Whenever a process, existing process or a new process is going to make a request for the new process, he must request in an increasing order. When the lower order resource is already allocated to a process, the new process cannot request that and must request increased order resources from the list. What does it mean? I know without diagram, it will not make a sense, okay? Okay, guys, so let's try to understand how this thing will occur. Okay, guys, so this was the previous diagram. I am going to save and clean this diagram. The system must have what? Let's suppose I have multiple resources. The system must create a resource list in an increasing order. For example, R1. For example, R2, a record for R3, a record for R4, and so on. Okay, complete this. So this is the list of resources. In this list of resources, resources will be added in a increasing order. 1, let's suppose R1, 2, let's suppose R2, 3, let's suppose the second instance of R2. This is also possible, okay? The second instance of R2. 4, R3, and 5, for example, R4. Okay. A process arrived, P1. P1 make a request. So P1 should request the first resource. Okay. Yeah, let me make it more understandable. For example, all these resources are the multiple instances of R1. Okay. As I told you that the system must take list resource base. Okay, so R1 is arrived, P1 is arrived, P1 make a request. So the P1 must make a request to the first instance of R1. Okay, and P2 arrived. If P2 need the same resources, then the P2 have to request for the second instance of the R1. Okay, P3 arrived. P3 want to make a request for the second instance of P3, sorry, is going to make a request for the second instance. No, it is not possible. Why? Because this is already occupied. If it is going to make a request for the first instance of R1, it is not possible. The system will not letting to use the R1 and R2, which are lower order process instance of the R1, because they're already hold, then the P3 should do what? The P3 should make a request for the increasing order. Remember, for what? For the increasing order. If P4 arrive and P4 want to have an instance, so they must request for what? For the fourth instance of R1. If the P4 is saying that this one instance is not sufficient for me, I'm going to make a request for the another instance. Yes, still one instance is free, and they have to make a request for the instance number 5 of the R1. Dear students, if the P1, P4 still saying that this 2 instant is not sufficient for me, I'm going to make a request. Then he will see if there are more free instances that they will make a request, it's okay. If they are going to make a request for the third instance, it is not okay. The system will not letting to request this. Why? Because they are already occupied and these are lower order processes, lower order instance of the resources. And a new process should make a new request in the increasing order, So right now, it is not an increasing order. That's why this will be not acceptable. Okay. So let's suppose if you guys are thinking that, okay, this is the R1. What about the R2? And here I have R2. R2 will have the same story. R2 will have the same story if it is multi-instance resource. So let's suppose this is the 3 instance of R2. Okay. R2. And the same approach will be followed here. If P1 need the R2 first instance, they make a request to here. If they need the second, they should make this, okay? Request here. And if P5 is arrived, P5 need the one instance of the R2, one instance of the R2, then they have to make a request for what? For the third instance. No one can make a request for the lower order resources because they are considering as occupied. But remember, they will not remain always occupied. They will be free. When they become free, then other processes can make a request. There's no problem. But during the occupation, they cannot make a request. If it is free instance, make a request in the increasing order. If not, stop and wait. Don't make any request. Okay, because the request will create waiting time, and that waiting time will cause what? That waiting time will cause the deadlock. And now, dear students, the circular wait problem is solved with the help of this. How? If you draw the same thing, like for example, I have R1 and R2, the same thing, R1 and R2. This is R1 and this is R2. P1 is making a request and the P1 is holding the P1 is holding R1 and P2 is holding R2. Okay. If this person create a request and this person also create a request, so what is occur? Circular wait occur. If they follow this approach, then there is no circular wait. You can see here, is there any circle? Of course not. Every single process is requesting a free resource in an incremental order, and the system have a list of resources. And now the circular wait condition become false. So circular wait here false. And here circular wait true. You know, when circular wait become true, possibility of deadlock. When circular wait become false, no possibility of deadlock. And why these mechanisms, finally, we solve what? The issue of deadlock preventions. Okay? Deadlock prevention is solved. Any question, dear students? This lecture is finished. Okay. In next lecture, we will try to discuss the deadlock avoidance method. Okay, guys. So the The first deadlock handling method is successfully finished. This method is successfully finished. Okay, done. And we will have discussion about the deadlock avoidance in our coming weeks. And these three matters will be discussed in our coming weeks. Okay.